Our students won't believe their work is important until we treat them like mathematicians and value the work they do in making sense of the math in our classrooms. Dr. Deborah Ball. We love this quote because it speaks so strongly to our formative task debrief. There's a lot of ways we theoretically could do a debrief, but the way we have designed the formative task debrief is centered around student work. We want to value our students and the work they produce as really meaningful mathematicians doing meaningful mathematic work. So let's think about a formative task. Thomas brought 5/8 of his leftover birthday cake to school to share. He gave away 3/8 of the cake to his friends. How much cake does he have left for himself? Show or explain how you know. So I launch the task, students start working, and it's time for me to circulate and monitor their work. And then it's time for me to actually select and sequence their work for my debrief, because I want to use actual student work under the dot cam in my debrief. There's only 9 samples of work on the screen. In the classroom, you'll have maybe 30 different samples of work. So it's really important that you solve the formative task ahead of time to help you anticipate the strategies that you're going to see. As you circulate, you'll look at the work and you'll think to yourself, what did this student do? Why do I think they did it? What does this work show about the math? And you are looking for 3 samples of work that tell an accessible and coherent story. So, although there's value in all of this work, and you can pause and look at it more, I chose 3 specific pieces. I chose sample A, sample F, and sample H. I'm not saying those are the only 3 or the correct 3, but those are 3 possible samples that you might choose. I wouldn't show them all at the same time, but I would take sample A, I would put it under the dot cam, and I would ask questions to help students unpack it and make sense of it. Then I would put sample F up. Same thing, ask questions, help them make sense of it. And then sample H. It can also be nice to show 2 samples at the same time. For example, I might show F and H at the same time after we've already looked at them separately and ask, I noticed this student had 2 pieces and this student had 2/8. How are those answers similar? How are they different? What do they mean 2 pieces? What do they mean 2/8? There's really interesting work you can do by analyzing their work both separately and together. Here are some examples of the types of questions that you might ask. Honestly, it doesn't need to be that deep. Our goal is to have students look at the work and make sense of it. You can always just start out by asking, what do you notice about this work? If there's models, you want to make sure we're unpacking the model. What do these 3 X's represent? How does this model match the problem that we read before? What is this circle here representing? I see an equation here. How does this equation match my picture? There's more examples of questions here, but the big idea is that we are trying to understand the work. We're looking at it as a valuable mathematical artifact that we can all learn from. And hey, I noticed that this one isn't even correct. That's all right, because there's still meaningful math there. There's an amazing equation. There's a great model. This would be fantastic if we were adding pieces of cake together. This is kind of the right answer to another problem. Our goal during the debrief is that we are elevating students' work by projecting that work on our dot cam and students' voices by asking them to unpack and make sense of the work. We, as teachers, are the facilitators. We steer the direction of the conversation by purposefully selecting and sequencing the work so that it tells a coherent and accessible story for all students and gets us ready to dive into guided instruction next.